The process of finalizing the route for a power transmission line is a complex and multi-step procedure that requires careful planning, analysis, and decision-making. Before reaching the stage where the route is finalized, several critical preparatory activities must be undertaken to ensure that the chosen route is the most efficient, cost-effective, and minimally disruptive. The first step is to conduct a preliminary feasibility study, which involves analyzing multiple potential corridors for the transmission line. This initial study considers several factors, including the geographical layout, existing infrastructure, environmental constraints, and technical requirements. One of the key aspects of this phase is the minimization of environmental and social impact. The proposed transmission line route must avoid or minimize interference with environmentally sensitive areas such as wetlands, wildlife habitats, national parks, and conservation zones. Additionally, densely populated urban areas should be bypassed to prevent disruptions to communities, reduce potential legal disputes, and avoid costly compensation for land acquisition. Land that is required for agricultural use or other economically important activities should also be avoided where possible to prevent conflicts with local stakeholders. Another critical component before finalizing the route is ensuring that the transmission line is compliant with regulatory frameworks. Local, regional, and national authorities typically impose strict regulations regarding land use, environmental protection, and infrastructure development. Before moving forward, utility companies must obtain permits and clearances from multiple governmental agencies, including environmental impact assessments (EIAs), land use permits, and safety certifications. This process requires close coordination with regulatory bodies to ensure that all legal obligations are met, which can be time-consuming but is essential for the success of the project. In addition to regulatory approval, securing land access or right-of-way is a major task. Negotiating with landowners, local communities, and other stakeholders is essential to gaining access to the land where the transmission line will be built. This process may involve purchasing land outright, leasing land, or securing easements that grant temporary or permanent access to the land for construction and maintenance purposes. These negotiations must be handled carefully to avoid legal disputes and resistance from landowners. In some cases, utility companies may need to employ eminent domain laws to acquire the land, but this is often a last resort due to its potential for generating opposition. Once these steps are completed, the preliminary route is selected and can then move forward to the detailed survey phase, which further refines the chosen path. The detailed survey is conducted immediately after the preliminary route has been selected and before the final route is approved. It is a critical step that involves gathering detailed, precise data about the terrain, topography, and potential obstacles along the selected route. The timing of the detailed survey is crucial because it serves as the foundation for designing the transmission line infrastructure, including the towers, conductors, and foundations. The survey must be carried out early enough in the planning process to allow for adjustments or modifications to the route if significant challenges are discovered, but it should also take place after the general route has been approved by stakeholders and regulatory bodies to ensure efficiency. During this phase, advanced surveying technologies are often employed to collect the necessary data. These include LiDAR light detection and ranging, GPS-based mapping systems, and aerial surveys using drones or aircraft. These tools allow for highly accurate measurements of the terrain, including elevations, slopes, and obstacles such as rivers, forests, roads, and buildings. The survey also identifies any potential construction challenges, such as steep inclines, rocky terrain, or soft soil areas that may require specialized construction techniques or design modifications. The data collected during the detailed survey plays a crucial role in designing the transmission line's infrastructure. It helps engineers determine the optimal locations for placing transmission towers, the spacing between towers, and the type and height of each tower. Towers need to be placed in such a way that they provide adequate clearance from the ground, buildings, trees, and other structures, ensuring safety and compliance with regulations. The survey also provides information on the alignment of the transmission line, ensuring that it follows the most efficient and safe path while avoiding obstacles and minimizing environmental impact. Additionally, the detailed survey helps identify areas where special structures or towers may be required. For example, if the transmission line needs to cross a large river, highway, or railway, special high towers or tension towers may be necessary to provide the required clearance. Similarly, in areas with difficult terrain, such as mountains or deep valleys, additional design considerations may be required to ensure the stability and safety of the transmission line. The timing of the detailed survey is important because it allows for early identification of potential challenges that could delay construction or increase costs. If significant issues are discovered during the survey, such as unstable soil, unanticipated land use changes, or unexpected environmental obstacles, the route may need to be adjusted before finalizing the design. Once the detailed survey is complete and the data has been analyzed, the project can move on to soil investigation and foundation design. The soil investigation phase occurs immediately after the detailed survey and is crucial for ensuring that the transmission line towers are properly supported by stable and reliable foundations. Soil investigations are typically carried out at each proposed tower location to assess the soil's composition, strength, and ability to support the weight and structural loads imposed by the towers. The timing of the soil investigation is critical because it must take place after the detailed survey has identified the tentative locations for the towers but before the final foundation designs are completed. Soil investigation typically involves drilling boreholes at key tower locations and collecting soil samples from various depths. These samples are then analyzed in laboratories to determine the soil's bearing capacity, composition, moisture content, density, and other properties. The results of these tests are used by geotechnical engineers to design appropriate foundations for the transmission towers. For example, if the soil at a particular location is weak or unstable, deeper foundations or special foundation types, such as pile foundations, may be required to ensure that the tower remains stable over time. In areas with strong, stable soil, shallow foundations may be sufficient. The timing of the soil investigation is important because the results directly influence the foundation design and construction schedule. If the soil investigation reveals problematic conditions, such as soft soils, high water tables, or areas prone to erosion or landslides, the design of the transmission line may need to be modified. In some cases, tower locations may need to be adjusted, or additional soil stabilization measures may be required. By conducting the soil investigation early in the process, engineers can address these issues before construction begins, avoiding costly delays and redesigns later in the project. The soil investigation also helps identify seismic risks in areas that are prone to earthquakes. In such cases, special foundation designs may be required to ensure that the transmission towers can withstand seismic forces. Once the soil investigation is complete and the foundation designs have been finalized, the project can move forward to finalizing the tower schedule. The tower schedule is finalized in two phases, the partial tower schedule and the full tower schedule. The partial tower schedule is typically finalized first, after the detailed survey and soil investigation have been completed for specific sections of the transmission line route.